There are several definitions more or less specific about the concepts of data, information, and knowledge. We'll use here simple definitions that should provide enough basis for our later presentation about knowledge management. In common, those definitions agree that these three concepts are different and that there is a certain order or hierarchy among them. Data are basic entities. Information are processed data submitted to an organization effort, while knowledge would be the absorbed information ready to be put into practice. Data are everywhere, as well as information, available in paper, electronically in the internet, or in computers and smartphones, and in people's brains. For example, we could consider a number data series such as 3, 8, 15, 21, and 30. But what does it mean? If we organize this data as days of the month of April when it rained in Rio de Janeiro, we have information. If we collect this data in all months of April in the last 10 years, we can acquire knowledge. That is, the frequency of raining in Rio de Janeiro in April. And use this knowledge, for example, when deciding if it's worthwhile to travel to Rio de Janeiro with the intention of sunbathing in April. In computing, the simplest information that can be stored or transmitted is called bit. It's a binary information. That is, it can only assume one of two states: yes or no, on or off, 0 or 1. But what you probably heard more about is byte. 1 byte is equivalent to 8 bits, so it carries more information than a single bit. The storage capacity in a computer is measured in multiples of bytes. Megabyte, approximately 1 million bytes. Gigabyte, equivalent to 1 billion bytes, and so forth. The information transmission, instead, is usually measured in multiples of bits per second. For example, gigabits per second. The information storage and transmission are phases of the knowledge generation process. But there is also the information processing and the understanding by a human being. Nowadays, the computer information processing is measured in calculations per second. Recently, a Chinese supercomputer reached the amount of 125 quadrillions per second. 1 quadrillion equals to 1,000 million millions, or the number 1 followed by 15 zeros. Even so fast, the supercomputer does not do everything the human brain does yet. Research shows that the human brain has an information storage capacity higher than 2.5 petabytes, which means 2.5 million gigabytes, equivalent to more than 600 million web pages. The processing speed of the human brain is inferior than a computer's. The neurons, the cells that form the brain, can be activated around 200 times per second only. But the human brain is still much more energy efficient per processed information than a computer, around 100,000 times more efficient. And it still can categorize and parallel process diverse information better than a computer, at least for now. Today, the humankind works with computer systems in a way that increases our ability in processing information and, consequently, generate knowledge. We'll talk more about explicit and implicit knowledge in our next video. Until then.